All right, chapter is thermal energy, and this is conduction, convection, and radiation. These are notes I made before when we had the other book. This book we're using is brand new, so back then it was a little bit different. Uh, the section was transferring thermal energy, not the whole chapter, but the notes match up. So, okay, so we talked about heat in thermal energy. Remember, thermal energy is the total of kinetic and potential energy in the particles of an object. Heat, or that thermal energy, can be transferred three main ways. All right. And the first one is conduction. The transfer of thermal energy between colliding particles. This means the particles have to be touching. Okay. Kinetic energy is transferred when these faster moving atoms collide with slower moving atoms. So all those little particles in there, um, the faster moving particles, when they collide with slower moving particles, remember, um, momentum, the transfer of momentum. Momentum is going to be transferred. That kinetic energy is transferred through momentum. So, what makes a good thermal conductor? What conducts this energy easily? What conducts the energy easily? Well, a material in which thermal energy is transferred easily is called a thermal conductor. Think about it. It's passed on by the collision of the particles bumping into each other. So an object that has that matter that has particles very close together, is going to transfer energy easier. Okay, when the particles are close together and they bump into each other a lot, that will be a great conductor of thermal energy. Okay, just the opposite of thermal insulators, where the particles are farther apart. So thermal conductors, we want the particles close together. Now, if you recall, density is a measurement of how close the particles are together. So more dense materials conduct better. Um, Lead, a piece of lead, something real massive and heavy, high density, is going to conduct energy, thermal energy, better than snow. Snow's not going to. It's there's big gaps in between the flakes and that, so um, it will not be a good conductor of thermal energy. There you go. Gases are poor thermal conductors. Solids and liquids are better thermal conductors. Convection. Convection is the transfer of thermal energy in a fluid by the movement of fluid from place to place. So, convection currents in water, convection currents in air also. All right. Um, Hot air rises, hot water rises. Convection is the transfer of thermal energy in a fluid. A fluid expands as its temperature increases. Remember, thermal contraction, thermal expansion. When something gets hot, it expands. So a fluid expands as it increases. Now, I want you to think about what I'm saying here. When we're measuring density, cold water has a higher density than warm water because cold water is condensed. The particles are closer together. When we warm the water up and the particles become farther apart, then it becomes less dense and it will move to the top of the liquid or the water. The warm water moves to the top simply because it's less dense. The density of the fluid, therefore, decreases. The warm water is less dense and is forced upward by the cooler sinking water. So the cooler water will move to the bottom, the less dense water moves to the top, and we get a convection current. As it goes to the top, it cools off and it drops down, and it starts a convection current in the water. The warm water transfers thermal energy to the cooler water around it. When the warm water cools, it becomes denser than the surrounding water and it sinks. This rising and sinking water forms a convection current. Radiation. Radiation is the transfer of energy by electromagnetic waves. Radiation can pass through solids, liquids, and gases, but the transfer of energy by radiation is most important in gases. The sun radiates energy down to the earth. Some of that radiation is reflected off by the surface of the earth. Um, the places it's reflected most, some of it is reflected by the atmosphere, but on earth, we have two giant ice caps on the north and southern poles, and those act like giant mirrors and reflect the radiation back out. Some of it is absorbed by the earth, and some of that radiation is absorbed in the atmosphere. When radiation strikes a material, some energy is absorbed, some is reflected, and some may be transmitted through the material. What makes a good thermal insulator? I kind of talked about that already. A good thermal insulator is something where the particles are farther apart. Materials that are good conductors of thermal energy, such as metals, are poor thermal insulators. Questions. Describe the difference between conduction and convection. Well, conduction is when the particles have to be touching. Convection is a change in density. A change in density. Blank is the transfer of energy by electromagnetic waves. That's radiation. Radiation. And what are some good insulators and what are some good conductors? So, good insulators, feathers, styrofoam. Think about going to the 7-Eleven or Mickey Mart when you get a drink like a big gulp or more so warm drinks. It's in styrofoam containers because styrofoam has a lot of space between the particles. There's actually air pockets in there. And I will tell you what is really cool. Um, my grandfather used to work for Dow Chemical in Michigan, and he was with the team. He was on the team that invented styrofoam. So my grandfather was one of the key personnel in inventing styrofoam. Pretty cool. What is a good conductor? Anything where the particles are close. Anything where the particles are close together. Uh, Make sure you watch the lecture to learn more about this. I will cover it a little bit more in the lecture. All right. Hopefully this helps, guys. Thanks.